Good day, sir. Good day, everyone. I am Michael C. Consorte from PSE 3C. Today, I'm going to discuss the two problems chosen by me about the torque and speed of a DC motor. So, let's have a recap about a DC motor. Let's introduce the DC motor. It is a type of electric motor that converts electrical energy into mechanical energy. It consists of two main components, the stator or the stationary part and the rotor or the rotating part. The torque and the speed of a DC motor are important parameters that determines its parameter. Yung torque, it is the rational force produced by the motors. It is measured in units of force multiplied by distance, such as Newton meters or pound feet. While the speed is the speed of a DC motors, refers to the rotational speed of its output shaft. It is typically measured in revolution per minute, or the RPM, or radians per second, or rad. So here's the problem. Number 1A. A DC shunt machine has armature and field resistance of 0.025 ohms and 80 ohms respectively. When it connected to a constant 400 volts bus bar and driven as a generator at 450 RPM, it delivers 120 kilowatt. Calculate its speed when running as a motor and absorbing 120 kilowatt from the same bus bar. B. Deduce the direction of rotation of this machine when it is working as a motor, assuming a clockwise rotation as a generator. So first, let's calculate the armature current when the machine is delivering 120 kilowatt as a generator. So the armature current is equal to P out over volt is equal to 120 times 10 raised to 3 over 400. That result to 300 ampere. Now we can calculate the speed when the machine is running as a motor and absorbing 120 kilowatt. So N is equal to V minus IA times RA over P out over engine plus IA times RA. Now substituting the value, we'll get 400 minus 300 times 0.025 all over 120 times 10 raised to 3 over 450 plus 300 times 0.25. So we get, or the final answer is 435 RPM. Therefore, therefore the speed of the machine when running as a motor and absorbing 120 kilowatt is 435 RPM. So the so the answer for letter B is since the generator or the machine is driving at 450 RPM as a generator and the speed when running as a motor is 435 RPM, we can conclude that the direction of the rotation is clockwise. So the direction of rotation of the machine when working as a motor can be deduced assuming as clockwise rotation as a generator. So the second problem is a 4-pole DC shunt motor has a wave-wound armature with 65 slots, each containing 6 conductors. The flux per pole is 220 milliweber and the armature has a resistance of 0.15 ohms. Calculate the motor speed when the machine is operating from a 250 volt supply and taking a current of 60 amperes. Here's the given for problem 2. Number of poles 4, number of slots per pole 5, number of conductors 6. The flux per pole is equal to 20 milliweber. We can compute that into 0.020 Weber. The armature resistance is 0.15 ohms. The volt is 250 and the armature current which is 60 ampere. So electromotive force is equal to volt line minus the armature current times the armature resistance. So substituting the value, we have 250 minus 60 ampere times 0.15. We have the electromotive force is equal to 241 volts. Next, In the formula of EB is equal to P times A times N times flux per pole over 60 times A. The symbol EB stands for the back electromotive force or the EMF. The back EMF is the voltage generated in motor or generator that opposes the applied voltage and is proportional to the speed to the motor or generator. Second, the back EMF is equal to P times A times N times flux per pole over 60 times A. This formula represents stands for the back electromotive force. The back EMF is a voltage generated in a motor or generator that opposes the applied voltage and is proportional to the speed of the motor or generator. The P times A times N times flux per pole represents the power in watts, which is not explicitly given, while the N is the speed of a motor in revolution per minute, or RPM, which we need to calculate. And A represents the number of parallel paths in the armature winding, which is given as 2. We have, or substituting the values, we have 241 is equal to 4 times 390 n times 0.020 over 60 times 2 times 2. Therefore, the speed of a motor is approximately 927 RPM. And that would be all. Thank you.